So this is chimere-2014 B manual. Here you can find more details over this model. So the output, this section is about output on the screen. Main thing is that output on the screen we will see, we will run the model now, we will run a simulation for 1 day. The output file which get generated out, the name, these are actually initial name of the starting name of the file, out, another is meteo, another is dep, another is ini. So the out file contains chemical concentration, like the species, different chemical species, its concentration. The meteo file contains the metallurgical data aggregated on chimere mesh. It means like the domain which we have chosen, it will be degraded on that domain. Dep.nc, it contains the dry and wet deposition fluxes, and these are this one is initialization, like the initial, the boundary condition. Using the boundary condition, the initialization file will be generated. Another is restart file. This file is about continuous run. Like we have started a simulation for 1 month, the October month, from 1 to 31. Then we want to make the run continuous, like the boundary condition which we have used at the first for October month, that will only be used for the October-November month. So in that case, we will run a continuous run, and for that it needs this file, this one, which will help it to go in continuous mode, and also continuous mode and restart as same, somewhat same. Another details is there. So any doubt about this control file, the main control file? These are some main section, date and time section, simulation domain. The name of the domain should be given here. Here given a new name, Avi02. These are division of the main domain into is in 5 into 3 15 parts. Actually, it's in 16 parts. 5 into 3 15 plus 1. Number of article layer 8. Top layer pressure 500. Ground layer pressure 997. Simulation output files, its name and other controls, like it vertical level in the output file. Concentration, say frequency 24-hour. Cumulative deposition frequency 12-hour. And another part is another section is emission section. This is also important, like which we want to switch on or switch off. Fire emission, point emission, biogenic emission, surface emission. Switch off is option 0 and switch on is option 1. Then comes the boundary condition. We want to build boundary condition, or we want to use boundary condition previously created. In that part, according to that, 3 options are given here. Chemistry options. This one is important. Chemistry mechanism, you can choose the chemistry mechanism here. Presence of sea salt, switch on or switch off options. Many other options as you can see here. We'll get more details from the manual. This is numerical part. So here also the physical time step and chemical time step is plays an important role. So here we have chosen 6. Physical time step as 6 per hour and chemical time step 2. This one is the and this section is also important. Here we build anthropogenic emission data at first, which is null file, because the global dataset doesn't contain our data of our domain. So at first we build null, then we feed values there, then we run the simulation again, giving option 2 that use that file and run the simulation. Don't create it. So this option is very important. At line number 112. Simulation output locations are given here. Static data. Static data is the data set used by chimere to run the model, like land cover data, Megan data, boundary conditions, basically gaseous species. Which one we want to use? There are some options, Bocard and LMDJ options. We have chosen LMDJ for BC. No touch aerosol is also LMDJ, and BC dust is OCAD. The next part is input output. Here are generally the file directories where we want to store our data, where we have stored our data, or where the file will be created. Is input output control that section. We don't need to modify this section. You have to just follow the same directory paths, because modifying this section will be not good. Now we directly go to the simulation itself. So control file, both of the control file are ready, domain list.nml and cimere.par. Now input data. Input data, we need two data. One is emission data and other is metallurgical data. Emission data, I have switched it off there. Like I am saying that I am choosing the option that Cimere have to build the emission data. So we are not feeding it with emission data. So this option is switched off. That Cimere will itself create the data and use the data to simulate. Metallurgical data will be provided by us. So here is the main folder section. Metallurgical data should be kept at this location as we have given in this control file. The location is given location as you can see, test meteo 2016. Test meteo 2016. It has the data which was created by Abhishek for this domain. Now we'll start our simulation. This is the main model. This is the command to run the model using that cimere.par as a control file. You can note this command. So here, as run duration is 1 day, you can see it has given in the output display. Preparation of chemistry. This one are the 8 vertical levels. 6 layer below 800 HPA and 2 layer above it, 800 to 500 HPA. So here are some other details. This section is important. Here the name of the domain. Here simulation over horizontal domain. Name of the domain is given. ABI02. Number of grid points. Anthropogenic emission. The option which want to build the emission file. So it's switch on. So it's saying that it will build anthropogenic emission. Fire emission are not requested. Fire emission not be built. Biogenic emission are built from files, dust species, so on. Yes. So at first it looked for the metallurgical file. So it got the file. It found the file. So it's running. Starting date, ending date is same as one day. So its starting date is 25:00. Ending date is 26:00. That 15 option, as you can see here in the control file, as I have said, that it will divide the domain into 15 part. Your file is really effective. My system is getting slower because I have started a simulation. Number of pal here you can see 5 into 3 15. number of domain it will divide its number of part it will divide its domain. There the domain division is stated here, like 15 part in 15 part. So it's starting from 1 to 40, 41 to 80, 81 to 120, 121 to 160. Like this, it have divided itself into 15 part. Okay. This one is a different kind of error coming. It's about vanillard scheme. Don't have to worry about that thing. We can get over it. So any doubt on this part? Then we can end our class here. हाँ? है तो
हेलो सर.
yes.
हाँ सर, एक्चुअली वो कंट्रोल फाइल का थोड़ा बता देना, कौन से पैरामीटर्स चेंज करने हैं कंट्रोल फाइल में, थोड़ा पता नहीं चला था. chimere वाला.
Control file में you don't have to change any parameter right now. These are the parameter which we are using. You have to keep one thing in mind, that this is for model 2014B.
Okay.
So we have changed some parameter for 2017B. So model wise also we need to change some parameter. So this one is 2014B version. So basically we change this number of article layer and the top layer pressure.
Okay.
So as I'm running my system, so I have chosen it in smaller domain size and smaller number of levels and this vertical pressure. So I have chosen for 500. Generally we do on 200, 300, 130. A number of article layers is 80. A number of if the input number of article layer is if we give here number of article layer 20, then also we need the output as number of 20 vertical layers. Output spaces detail can be used as low and full. That option varies. Another part is from here we have seen that the dust option, BC dust option, go-kart and LMDJ plays a role on the AOD part. Right? AOD part. Any other doubt, Abhishek?
सर ये 112 की लाइन जो बताई थी ना आपने, वही पर बता देना. हाँ, 112 पे कुछ बता रहे थे आप.
ये एक्चुअली हम लोग जो इसमें अभी अभी जो रन हो रहा है ना, इसमें जो एक एमिशन करके मतलब जो एंथ्रोपोजेनिक एमिशन डेटा होगा वो ये नाल जनरेट, क्योंकि इसका पास वो वैल्यू है नहीं, मतलब इन लोगों के पास जो ग्लोबल डेटा सेट है उसमें इंडिया है नहीं, उसमें उन लोगों का एक्चुअली ग्लोबल डेटा सेट है ही नहीं इसका एंथ्रोपोजेनिक एमिशन का, तो उसमें लिमिटेड है, उन लोगों का यूरोप का ऊपर है, तो उस हिसाब से हम लोग तो इंडिया के ऊपर रन करें तो उसका नाल जनरेट होता है। तो हम लोग क्या करते हैं, क्योंकि हर एक डेटा सेट प्रोवाइड करने वाला डेटा सेट का भी एक फॉर्मेट रहता है, मतलब उस फॉर्मेट में देंगे तो वो उसको रीड कर पाएगा, नहीं तो नहीं कर पाएगा। तो फाइल फॉर्मेट भी रहता है और हेडर फाइल का भी फॉर्मेट रहता है। सो गेट दैट हेडर फाइल फॉर्मेट, we have to at first run it with option 1, that will build a null file. Then we have to add data in that null file, like the data which we want to add, like we generally add the BC data, OC data, AS3 data, INO data, SO2 data. We add in that null file. After adding that file is not a null file, it contains that data. Then we choose option 2. Like option, what is option 2? It stated that you don't need to build, you have to read the file. So when we choose option 2 and run the simulation again, that is our final simulation, not with option 1.
Okay.
Got it?
Okay.
At the point.
Yes. Yes.
At first we will run with option 1, so get the
Option
null
one, and
file.
then after that, yeah, and
Then
after that we
we
have to
run,
add them, yeah, parameters.
then we will, that will
Okay.
give us the final output.
Okay. Yes.
Okay. Somehow. Okay, let's do another experiment with this. As the vanilla stream was coming, let's change the vertical pressure level. Then see what. If follow my steps, which I. Okay, one thing I forgot to show you is the where the output simulation output comes. So as I've given the location as outputs, so the metallurgical boundary conditions and initial boundary conditions. This one, this file I was talking about, we have to create a null file. This is null file. As I open this file, you can see this will be a null file. Let's see view. Vicar-Coa, BC. So this is a complete null file. It has no values. NO is also contains no values. NH3 contains no values. None of these species contains values because our domain doesn't lie on the data provided by chimere itself. So it is unable to provide data for our domain. And here where the simulation output is generated, you can see this file. This file is the actual output which contains the concentration species concentration. Okay, let's open with its panoply so we can see the domain size. So let's open relative humidity, which will have value. Here. 7827. Here we can see the origin of this one is 73. Start from 73, 23, and CTM domain origin is 74, 24. CTM domain. In the CTM domain, does your station comes, Abhishek?
Yes, sir. Yes, sir. Yeah.
Are you sure?
Yes, sir. Yes, sir.
All the station come properly?
Yeah. Yes. Yes. Sir. Yes. Delhi coming in. Yeah. Yes, sir. All the stations are.
So you can note this CTM domain then.
Sir.
This one.
Okay.
You can see our Indian domain is also here. India, when we do simulation over India, complete India, it is Indian domain specification. This one is for IGP. This one was, these are for all from Europe. These domains are for Europe. You can see France domain. Please. You have started another simulation, but I have also deleted the previously created file because sometime the previously created file corrupt the other files. The model itself get confused.
Sir, you are muted. Hello.
Sorry.
हाँ वो आवाज नहीं आ रही.
इसमें मैंने जो लास्ट चेंज किया वो एक्चुअली देखो, ये फिजिकल केमिकल टाइम स्टेप जो है, ये कॉम्बिनेशन एक इम्पोर्टेंट रोल प्ले करता है. एज for the suggestion given here in this control file, down of the control file, you can see it's clearly mentioned that physical time step 6 and chemical time step 1 is for fine, and for more finer grid like 5 to 10 kilometer, take at least 4. So I have taken the 4 also. I think we can go ahead with the 6 also, because our dimension is 5 kilometer. So if it fails, then we go for 6 for grids of 5 kilometer. It's failing. And again we change it to 6.